Morning, guys. We are dealing with optimization. So I selected some few questions that we have to solve. Question number 1 is this one. They say a car moved distance s meters in a time t second according to the formula s equal to 3t to the power 3 minus 2t to the power 2 plus 4t minus 1. Here the question: determine the velocity and the acceleration of the car when t equal to 0 and when t equal to 1.5 second. All right, so what is the velocity? We know that the velocity is the differentiation of the displacement. So v of t is equal to s of t, like this, differentiated. So I have f of t, s of t, which is this. I'm gonna differentiate this function. It's gonna give me 9t squared minus 4t plus 4, and that one equal to 0. Okay, the differentiation of 1 is minus 1. It's gonna give you 0. All right, so they say we have to find or determine the velocity at t equal to 0 and at t equal to 1.5. Okay, I will do only one. At t equal to 0, my velocity will be equal to what? I just have to replace t by 0. You can clearly see that your velocity will be equal to, if I replace 0, it's gonna give you 0. If I replace here 0, it's gonna give you 0. So I will end up with 4. Because it's the velocity, the unit is meter per second. All right, and then they told also to find at t equal to 1.5. Your v will be equal to what? It simply means you have to take this, you replace it there. All right, so which is like this: 1.5 squared minus 4, 1.5 plus 4. So you punch your calculator and you get your answer. All right, so let me go to how to find the acceleration. The acceleration is the differentiation of the velocity. All right, that is this, or it means it's the differential is the second derivative of the displacement. So this will be what? I will just take this function, differentiate it once. I will differentiate my velocity, which will be 18t minus 4. All right, and then they ask us to find the acceleration at that point at t equal to 0. So at t equal to 0, my acceleration will be what? At t equal to 0, my acceleration a will be equal to minus 4 meter per squared. All right, so the other one will be, you have to replace this, and then you'll find your answer. All right, okay. When I was doing a tutorial earlier on in class, someone asked me if I can solve question number 2. So here I think we will try to solve the 3 first example, and then we'll solve the 3 last example. We're gonna select, it was this one, question number 7, question number 8 and question number 10. So we're gonna solve these questions. All right, let me solve the second question. All right, we have question number 2. It says a particle moves according to the equation S equal to 3 cos 2t plus 4 sine of 2t in centimeter. You are asked calculate when it stopped momentarily for the first time, okay? And then the displacement at that point in time and the acceleration when t equal to pi over 3 seconds. All right, number 1, we have to differentiate this function. Okay, s of t prime will be equal to the differentiation of 3